Good day from Chem Help ASAP. If you are watching these videos as a series of playlists, then you'll notice that we've moved from learning about ideas to actually doing chemical reactions. Before we get too deep into reactions, I want to introduce a method of thinking about chemical reactions. This method is reaction triangles. This is a method I learned from the late Seihan Ege, who was a chemistry faculty member at the University of Michigan back when I was in Michigan's chemistry graduate program. When you see reactions in general chemistry, they tend to be written as balanced equation. This top reaction is an example. Starting materials are on the left, products are on the right. Everything in the reaction is equally important because we're keeping track of every atom. Organic chemistry is a bit different. Let's look at the lower part of the slide. Reactions instead have a key starting material. Often the key starting material is the largest organic molecule in the reaction. The structure of the key starting material is written in front of the reaction arrow. Almost all reactions have more than just the key starting material. Other chemicals in a reaction are called reagents. These are normally written above the reaction arrow. Below the reaction arrow might be additional information. The reaction conditions, such as reaction time, temperature, or the solvent. The space above and below the arrow is important in organic chemistry. In contrast, in general chemistry, the arrow is normally left empty. The main product of the reaction is written to the right of the arrow. Note that organic reactions are almost never balanced. Minor products are often considered to be waste, and they are ignored. So, how we draw reactions in organic chemistry is very different from general chemistry. Great, but what does this have to do with reaction triangles? Reaction triangles are a way to think about organic reactions. We can think of our starting material as A, our reagents as B, and product as C. These kind of make a triangle. In organic chemistry, if you know the identity of two of the three parts of the triangle, you should be able to determine the third part. On the bottom of the slide is a real reaction. 1-bromobutane, our starting material, A, reacts with sodium azide, a reagent, B, to give 1-azidobutane, our product, C. This reaction also forms sodium bromide, but we'll ignore that as a side product. We won't even show it. We can turn this one reaction into three questions. You could be given the starting material for the reaction with the reagent and be asked to fill in the product. You could be given the starting material and the product and be asked to provide the reagent. You could be given the reagent and the product and asked to provide the starting material. Reaction triangles are a simple yet effective way to focus upon what you know and do not know in a reaction. The unknown part that completes the triangle must fit with the other two parts.